Good afternoon, colleagues, or good evening. Um, Glad to meet you again for this continuation of the lecture we had, lecture one on fundamentals of distributed system. So we are going to continue from where we ended. Just to recap, we looked at fundamentals of distributed system, where we look at, of course, when we started this topic, we looked at the definition of distributed systems or distributed computing. We looked at the definition. Then we looked at the evolution. Okay, where has it come from, and so on, and where are we heading to, and what is the purpose, and so forth. Then the last aspect that we are going to look at is the distributed computing system models. But before we go straight to look at so you find that the main aspect we looked at was that the computer architecture basically consists of interconnected multiple processors. Processors are basically of two types, of what we call tightly coupled systems as well as loosely coupled systems. We talked about this. You can refer to our first video. It's online, and then you'll be able to understand. Okay, those were explained in detail. Then we looked at the evolution of distributed computing systems or distributed systems. We looked at how these came into being, how computer systems underwent evolutions. Okay, evolution starting from 1945 to date, and this formed part. Yeah, so we discussed quite a lot in that regard. So today we'll look at what we are calling distributed computing system models, or distributed computing distributed computing systems. This is what we are going um, to look at. So it's important. It's important actually to understand that various models are used for building distributed computing systems. Okay, there are various models that have been derived actually to build distributed computing, or basically distributed systems. Now, these models, again, it's important to understand that this model can be broadly classified into 5 categories. Okay, so we are talking about the categories of the models that are used to build distributed computing systems. So they can broadly be classified into into 5 categories. We have what we are calling the mini computers, workstations, workstation servers, processor pool, and what we are calling as hybrid. Okay, so these are the classification of the distributed computing model. So they are classified into uh, 4 categories. The fifth one is basically the hybrid model that takes into consideration both the combination of some of these models. So they are briefly described below. We are going to discuss each of these. Okay. The mini computer model. Mini computer, from mini computer. So if you look at the mini computer model, this is a simple extension of the centralized time sharing system. Okay, is actually the sharing system. That's the mini computing computer model. It's a simple extension of the centralized time sharing model. Okay, we're talking about time sharing system. Okay, so we have a figure 1.2 here where we are saying a distributed computing system based on this model consists of few computers. Okay, and they may be large supercomputers as well. But now these computers are interconnected by a communication network. Okay, so we are talking about the model that this is based on. Okay, the model that this is based on basically consists of okay, it consists of um, few. Okay, it consists of few mini computers. Of course, you could also have supercomputers, mainframe, and so on. Okay, but now these few computers are interconnected by a network model. They're interconnected by a communication network. So each mini computer, okay, so each mini computer usually has multiple users simultaneously logged onto it. Okay, so all these users, they are simultaneously logged to this mini computer. Now for this, several interactive terminals are connected to each mini computers. So these terminals are there for the purpose of interactions. Interaction. So each user is logged onto one specific access to other mini computer. Okay, so each user is logged on to one specific mini computer. Okay, but despite that, users have access to other remote computers. Okay, so we are saying now that the network allows a user to access remote resources that are available on some machine other than on one on which the user is currently logged on. Okay, so we are saying that you have this of these mini computers that are in communication network. But what we are saying is that through the network, these computers are able to exchange information between themselves. Okay. So now, the mini computer model may be used when resource sharing, such as sharing of information databases of different types, with each type of database located on a different machine with remote user is desired. So this is the condition under which a mini computer model can be used. Okay, so you need to use this model when you are sharing resources. Okay, you are sharing resources with remote users. Okay, when you want to share resources with remote users. So the early ARPANET is an of a distributed computing system based on the mini computer model. The early ARPANET, we know this was the first network that was created by the American Defense Force in order for them to be able to start sharing information in terms of the network and so on. Okay, so this was part of the mini computer model. Okay, we have a diagram here to depict that. Okay, you could see that you could see we have mini computer here. Of course, you have other terminals here. Then we have mini computers. Then you have terminals, mini computer, other terminals, mini computer. Then we have the communication network here. Okay, this is the communication network. So what's happening is here, the users, each mini computer is able to access the resources located on another mini computer via the network, the communication network. Okay, so that's what we are talking about. Okay, so a distributed computing system based on the mini computer model. So this is a very good example, and this is the diagram that we need to provide in case you are asked about you sketching something to depict the mini computer model. Okay, mini computer model. Workstation model. This is another model. In addition to mini computer, we have workstation model. Okay, that's in addition to other computers. We have workstation model. Okay, so this one is shown in figure 1.3. A distributed computing system based on the workstation model consists of several workstations. Okay, so when you talk about workstations, we are talking about several computers or several machines or several nodes. And now these nodes are interconnected also by a communication network. Okay, so these are interconnected by a communication network. So a company's office, a company's um, a company's office or university department may have several workstations scattered throughout a building or campus. Okay, okay. We are saying a company's office or university department may have several workstations. These are scattered throughout a building or a campus, and each workstation is equipped with its own disk, serving as a single user computer. Okay, so of all these, okay, or a company's office or university department, which has several workstations scattered throughout the building, and each of these workstations is equipped with its disk and serving as a single user computer, meaning it can operate independently. Okay, you're able to operate this independently. Okay, so it has found that in such an environment, at any of the workstation are idle, not being used, okay, putting in the wastage of large amount of CPU time. Okay, so here what we are saying is that in mini computers, in this workstation mode, we have several workstations or several standard computers, and these are dotted around the campus or an office. You can imagine with this case, in this case, it is only possible, okay, it's only possible when it's only possible um when when people are working. Okay, when people are working, that's when now you tend, okay, this is when you tend to get to so we are saying it's been often found that in such an environment, at any one time, especially at night, you find that most people have knocked off. Okay, most people have knocked off, and they cannot be using the computers at their offices, or they cannot use the computers at campus. As a result, we have a lot of wastage in terms of CPU time. So therefore, the idea of the workstation model is to interconnect all these workstations by high-speed local area network, so that idle workstation may be used to process on to other workstations and do not have sufficient processing power at their own workstation to get their job processed efficiently. So now, here what we are trying to say is that if the machines are interconnected, this disparity in terms of how the computers are connected, how they are used, how the resources are utilized, particularly the CPU time. So this implies that uh, at night, when people are not working in their offices, it means they dead. But now, what has come on board now is this kind of a model. What has happened is that these workstations are connected in local area networks, so that these computers are able, for those with low processing capabilities, they're able to take advantage of other workstations that are connected to their network, so that they can process their data without any problem. Okay, so it's important to note that in this model, a user log on to one of the workstation called his or her workstation and submit jobs for execution. Okay, so this is what happens. A user logs on to one of the workstation that he belongs to, okay, and then submit the job for execution. Now, when the user system finds that the user's workstation does not have sufficient processing power for executing the processes of the submitted job efficiently, it transfers one or more of the process from the user's workstation to some other workstation that is currently idle and gets the process executed there. Okay, and finally the result of the execution is returned to the user workstation. Okay, so this is what, so you have this onto your machine, which is connected to a local network, and submit your work. But if it turns that your machine is not capable or it doesn't have enough processing power, then the job that you've submitted can be taken to a different workstation that has enough processing capability to ensure that it is worked on. So here, this is what happened. We have all these workstations. These workstations are interconnected using the communication networks. Okay. So now what happens is that all these are able to interconnected. They are interconnected using local area network, and one has to log on to the local area network in order for them to have their work processed. So this is a distributed computing system based on workstation model. So this model is not so simple to implement as it might appear at first sight, because several as follows. This is according to Andrew Tenenbaum in 1995. He discovered that this workstation model has several issues, but from the side, from the look of things, you look at it like it is simple. It's only connected, maybe like where you connect using certain devices, and then the machines are able to exchange information among themselves. But this is not the case. So if you compare that to this one, this is mini computer, where again you have the workstation, the communication network, then you have the mini computers that has terminals, okay? But in the other model, we only have the communication, the workstation, and then communication network. So now we are saying this is not so simple to implement, okay? There are several issues that need to be resolved before you think this model. One, you need to look at you have to answer questions such as, how does the system finds an idle workstation? Okay, how do you know to say, okay, machine A is idle? Okay, therefore, when I submit my work, it will be processed by machine A, which has high processing capabilities or high processing power. Then the other thing is, so the key question is, how does the system find the idle workstation? Okay, that's the key question. How do you find the idle workstation? Then the other question to ask is, how is the process transferred from one workstation to get it executed on another workstation? Because if you look at the diagram there, we only have one communication network. Okay. Now, how do you transfer the work from one station to the other? Now, the third is that, what happens to a remote process if a user logs onto a workstation that was idle until now and was being used to execute a process of another workstation. Okay. So these are the issues, according to Andrew Tenenbaum, that you need to address before you start thinking of implementing this model. Though this model looks to be quite simple in the when you look at it, it appears to be simple and straightforward, but that is not the case because one has to answer these questions. Now, we are told there are three commonly used approaches for handling the third issue, okay, which are as follows. Because you are talking about what happens, okay, you understand. So okay, this machine A is idle, and then you decide to submit your work to that machine. Then all of a sudden, somebody logs onto that machine and want to execute data using that machine. How do you handle such a situation? Okay, so that's the question. So the first approach is to allow the remote process share the resources of the workstation along with its own logged on users processes. Okay. So you need to share the resources of the workstation. Okay, you share among the machines on the communication network, and you need to know the logged in users. So now this method is easy to implement, but it defeats the main idea of workstation serving as a personal computers, because if a remote processes are allowed to execute simultaneously with the log on users on processes, the logged on user does not get his or her guaranteed response. So this may look like this, but it's not really that good. So the second approach is to kill the remote process. Okay, the first approach we are saying is to allow the remote process to share the resources of the workstation. You share the resources of the workstation along with the logged on users processes. You share that. Now, the second approach is to kill the remote process. Okay, you kill the remote process. That is the second approach. Okay, so now the main drawback of this approach, okay, the main drawback of this approach is that of this method are that all processing done for the remote process get lost, and the file system may be left in an inconsistent state, making this method unattractive. Okay, so this method may be unattractive due to this reason. Okay, so that's the second approach. Third approach, so that its execution can be continued there. It back to where it came from. Okay, you migrate it back to where it came from, so that the with execution from there. Implement also because it requires the system to support preemptive process migration facilities. Okay, so it's not that easy. So you may think of implementing the workstation model, okay, in distributed system, but it comes with its own drawbacks. Okay, it comes with its own drawback. For a number of and better scalability, more particular type of distributed computing system. Okay, so servers are often used. Okay, this is for of reliability and better scalability. Okay, for you to guarantee reliability and for you to guarantee that the system should be able to scale in case of new workstations being added to the communication network. The operation should continue without any interruption. For example, there are many be multiple file servers, so you need multiple file servers, each running on a separate mini computer and cooperating via the network for managing the files of all the users in the system. Now, due to this reason, a distinction is often made between the services that are provided to clients and the servers that provide them. Okay, a service is an abstract entity that is provided. That is a service. Is an abstract entity that is provided by one or more servers. For example, file servers may be used in a distributed computing system to provide file service to the user. In this model, a user log on to a workstation called his or her home workstation. Normal computation activities required by the user's process are performed at the user's home workstation, but requests for service provided by special servers such as the file server or database servers are sent to the server providing that the type of the server of the service that performs the user's requested activity and returns the result of request processing to the user's workstation. Okay, therefore, in this model, the user's processes need not to be migrated. The user's process to the server machine for getting the machines. For better overall system performance, the local disk of a disk workstation is normally used for such purpose. Okay, as the storage of temporal files, storage shared files, storage of shared files that are rarely changed, paging activities in virtual memory management, and changing of remote accessed data. So this is done, performed on a local machine or local workstation disk. As compared to the workstation model, the workstation server model has several advantages. Okay, the workstation server model has several advantages. Okay, and these include, in general, it is much cheaper. It is much fast disk that are accessed over the network than a large number of disk workstation, with each workstation having a small slow disk. So the aspect of cost in terms of then diskless workstation are also workstation from a system maintenance point of view. Workstation. So it means that backups and hardware maintenance are easier to perform with few large disks. With a few large disks than with many small scattered over a building or campus. Okay, So furthermore, installing new releases of software such as file saver with new functionalities is easier when the software is to be installed on a few file saver machines than on every workstation. So the aspect of installation comes in. Okay, the aspect of installation comes in. Then in the workstation saver model, um, since all files are managed by file servers, users have the flexibility to use any workstation and access the files in the same manner, irrespective of which workstation the user is currently logged in. So in this case, we are talking about the sharing of files regardless of the machine on which it is the users are logged in. So note that this is not true with workstation model, in which each workstation has its local file system, because different mechanisms are needed to access local and remote files. Okay. In the workstation server model, the request response protocol described above is mainly used to access the service of the server machine. Therefore, unlike the workstation model, this model does not need a process migration facility, which is difficult to implement. Did you go forward? So therefore, the request response protocol is known as the client server model of communication. In this model, a client process, which is in this case resides on a workstation, sends a request to a server process, which in this case resides on a mini computer, for getting some service such as a block of a file. So the server executes the request and send back a reply to the client that contains the result of the request processing. So we're talking about this client server model in this context. So the client server model provides an effective general purpose approach to the sharing of information and distributed computing resources. Okay, this is very important because we have what we are calling the server that contains all the information, and then you have the clients. Okay, so the clients are able to make requests through to the server, and the server is able to provide the response. It is not only meant for use with workstation server model, but also can be implemented in a variety of hardware and software environments. So the computers used to run the client and the server processes need not necessarily to be workstations and the mini computers. They can be of many types, and there is no need to distinguish between them. So the type of the computer in use may not necessarily be of importance in this context. So it is even possible for both the client and the server to processes to be run on the same computer. Moreover, some processes are both client and server processes. That is, a server process may use the services of another server appearing as a client to the latter. Okay. So that's about the client server paradigm. So a user has a guaranteed response time. Because workstations are not executed workstations are not used for remote processes. However, the model does not utilize the processing capability of idle workstations. Okay, so that's about the workstation model. Now we have the processor pool model. Okay, the processor pool model. The processor pool model is based on the observation that most of the time a user does not need any computation power, but once in a while he or she may need a very large amount of computing power for a short time. Okay, so that's why the processor pool model draws its strength. It actually draws its strength in the fact that it's not every time that the user needs much processing power. Okay, but at least once in a while, that is when you tend to require the user to use the much needed processing power, e.g. when compiling a program consisting of a large number of files after changing a basic shared declaration. So therefore, unlike the workstation server model in which the processor is allocated to each user, in the processor model, the processors are put together to be shared by the users as needed. Okay, so only when the processors are needed are they now able to share the are they able now to be shared and then use the much needed high processing capabilities required. So the pool of processors consists of a large number of microcomputers and mini computers attached to the network. And each processor in the pool has its own memory to load and run a system program or an application program of a distributed computing system. Okay, so the large number of microcomputers attached to the network, and each processor in the pool has its own memory to load and run a system program or an application program of distributed computing system. As shown in figure 1.5 in the pure processor pool model, the processors in the pool have no terminal attached directly to them, and users access the system from terminals that are attached to the network via devices. Okay, via devices. Okay, so these terminals are either small diskless workstation or such as X terminals. Okay, so a special server called a RAM server manages and allocates the processors in the pool to. So now, when a user submit a job for computation, an appropriate number of processors are temporarily assigned to his or her job. Okay, they are temporarily assigned to his or her job by the server. For example, if the user's computation job is the compilation of program having n segments in which each of these segments can be compiled independently to produce separate relocatable objects, files, and processors from the pool can be allocated to this job to compile all the n segments in parallel. So when the computation is completed, the is completed, the processors are returned to the pool for use by other users. Okay, so that's what we are talking about. So in the processor pool model, there is no concept of a home machine. That is, a user does not log on to a particular machine, but to the system as a whole. Okay, so here you are concerned with logging to the entire system, not a specific machine. Okay, so that is the model. The other one is the hybrid model. So out of the four model described above, the workstations server model is the most widely used model for building distributed computing system. The workstation server model is the most widely used model for building a distributed system computing. So this is because a large number of computer users only perform simple interactive tasks such as editing jobs, sending electronic mails, and executing small programs. So the workstation server model is ideal for such simple usage. However, in workstation environment that has groups of users who often perform jobs needing massive computation, the processor the processor pool model is more interactive. Okay, so here we are saying that in an environment, okay, in an environment where users perform jobs that involves massive computation, then it means the workstation server model may not be ideal. So what will prove to be ideal in this case will be what you are calling the processor pool model. Okay, and this will be interactive, will be more attractive and suitable. Okay, so to continue the advantages of both the workstation server and the processor pool model, okay, we have what we call the hybrid model. Okay, so the hybrid model may be used to build a distributed computing system. Okay, you may choose to use the hybrid model. Okay, so the hybrid model is based on the workstation server model, but with the addition of a pool of processors, so that whenever the workstation choose to do computations that involves massive work, then they would make use of this pool of processors in order for them to process the data quickly. So the processors in a pool can be allocated dynamically for computations that are too large for workstations or that requires several computers concurrently for efficient execution. Okay, so this is how the processors in the pool can be allocated. It's not like they can be located sequentially or statistically, but they are dynamically depending on the machine that needs much distributed power or computation power. So in addition to efficient execution of computation intensive jobs, the hybrid models gives guaranteed response to interactive jobs by allowing them to be processed on local workstations of the users. Okay, so you can process the work on the workstation of the users using this kind of um, interaction or this kind of model. However, the hybrid model is more expensive to implement than the workstation server model or the processor pool. Okay, in terms of costs, again, this one becomes more expensive. It's more expensive than the others mentioned above. So this marks the end of our first lecture, and in for your own processing, for your own revision, I'd rather you go through these questions so that you answer them and see whether able to understand what has been discussed in this lecture. So the first question is you have to differentiate between real-time sharing, parallel processing, network, and the distributed operating system. So that's the first question. Then the second question is in what respects are distributed computing systems better than parallel processing systems? In what context? Okay, in what respect are distributed computing system better than parallel processing system? So that's the second question. Third question, you have to discuss the main guiding principles that a distributed computing or operating system designer must keep in mind for good performance of a system. Okay. What are the guiding principles that a distributed operating system designer must keep in mind for a good performance of the system? Then, what are the major issues of designing a distributed operating system? What are the major issues of designing a distributed operating system? What is the major? The other one is what is the major difference between okay, network OD and the distributed operating system? Okay, network design operating system and operating design. Okay, so also why is scalability an important feature in the design of distributed operating system? Discuss the guiding principles for designing a scalable distributed system. So you have to answer these few questions. There are 6 questions which you are required to answer, and we'll have them discussed. In our next meeting, we are going to start looking at the issues in designing a distributed operating systems. What are some of the issues? Now, this unit will be structured as follows. We'll look at issues in designing a distributed operating systems, the aspect of transparency, then performance, then scaling transparency, then reliability, then fault avoidance, fault tolerance, then fault detection, and flexibility. So this is what you are going to look at. Then we'll look at the performance as well as the scalability issues. So when you answer the questions above, at least it will give you a clear understanding so that when you start looking at this, you will have a clear understanding of what is needed. I think this marks the end of our first lecture on on fundamentals of distributed systems or distributed computing. In our next lecture, our next video, we're going to talk about the issues in designing a distributed operating system. I thank you. Evening, my brother. How are you? I'm okay, thank you. How's the day going? We thank God. Yeah, just conducting my lectures in the car inside the kids are just yeah, some virtual classes. It's not so good. That's a big issue. Yeah. Mm. Thank you so much, my brother. We'll see you around. Thank you.
Daddy, who's that on your phone? What's his name? Huh?